Hi, everyone. Welcome to the DevOps Continuous Integration and Deployment on AWS talk. We're about to get started here. I'm Leo Jadnowski. I'm a solutions architect here at Amazon Web Services. And this is Dave Beck. He's the technical director at the National Novel Writing Month. So I'll be telling you about some of our services that we have that will allow you to do DevOps and CI and CD on our platform. And Dave will be telling you about his journey kind of into using these tools and into automation, all these good things. So first of all, what is DevOps? So DevOps, it's kind of become a buzzword, so there's a lot of different meanings of it and a lot of different use of it, but really what it means is it's the practice of operations and development engineers participating together in the whole application lifecycle process, right? So from design to development to monitoring and production support. So really what it means to me is when you have operators who know something about engineering and you have engineers who know something about operations. So you use automation and you kind of do things in a smarter fashion. So an important part of that is to utilize continuous integration. What is continuous integration? So continuous integration allows you to make it so that when you have changes to your code, so you've got your code sitting in a software, source control, right? And as soon as you change a certain branch of your code, that code will then automatically get pushed, whether it's production or to staging, or however you want to set up that pipeline. So it'll only get pushed, though. It'll only get deployed after passing tests. So we make sure that the code works, that it's functioning as it should, and then it gets deployed. So what this allows you to do is instead of having your deployments happen once a year, 4 times a year, or having these big monolithic changes, you have iterative small changes. This makes your changes not scary. It makes you able to detect bugs really quickly, so it's less scary to do deployments. And this encourages you to then automate your deployments. If you update your software 4 times a year, it's easy to say, okay, let's just do this manually. It's not a big deal. If you update your software 10 times a day, at that point, that doesn't scale, and you have to automate your deployments. And this allows you to be much more agile, and this allows things to be much more rapid, right? So what does this actually look like? So you're the developer, you're writing your code, you've got your source code repository, so Git, Subversion, GitHub, CodeCommit, whatever it is that you prefer to store your source code in. And you've got your continuous integration server. So that could be AWS CodePipeline. When that comes out, it could be Jenkins, it could be Travis CI, again, whatever you prefer to do your continuous integration with. And then you've got your project management software. So project management software just lets you keep track of your tasks. So what are you working on? What do you have to do in the next sprint? So on and so forth. So you pick your tasks from the project management server that you're working on. You submit your code, so you do the actual work to complete your tasks. You submit your code. This then kicks off a build. So it could either automatically kick off a build in your continuous integration system, or you could have a recurrent build. So you could have it every night, let's do a build. So once a day at 2 a.m., it's going to rebuild all your software, and it's going to run tests against it, and load tests, and security tests, and all that good stuff. So after your build's complete, or actually the way the build works is it's going to fetch your code, whatever commit that you want to build, out of the source code repository, and it's going to run tests on that code. So the tests are going to be functional tests, unit tests, security tests, all that good stuff. And if the tests fail, it's not going to deploy. If the tests pass, it's going to deploy. So you go to your project management software, and you see the results of your test. And then assuming the tests pass, you're going to actually do a build. So that build's going to give you output. What is that output? Well, you're going to be building documentation. You're going to be building binaries and packages, which is what's actually going to get deployed onto your instances to deploy the new version of your code. And you're going to get notifications. So part of DevOps is to have visible operations. So everybody that's involved in a piece of software, from the developers to the operators to project managers, they should all get the same notification. So they should all know what's going on. Is my product up? Is it fast? When has the deployment happened? So that should all be part of this process. Now, something that I've recently seen, which is now possible, is to do immutable infrastructure. So instead of updating the same set of instances with your new software, you just build new instances and new infrastructure every single time you deploy. So using AWS CloudFormation, you could bring up a whole new stack. So your load balancers, your databases, your instances, your VPCs, really everything that's your whole stack that comprises your stack, you could just build a new copy of it every time you deploy. And instead of updating your existing instances and updating your existing things that you have running now, you could just bring up new instances through building new Amazon machine images. Or if you're using Docker, you could build new Docker images and bring up new Docker containers. So this has several benefits, right? If you're building new infrastructure every time you deploy, or for all major deploys, from a security perspective, it's really good, right? So you have instances that are short-lived. So if something happens to your old instance, it gets compromised, well, they're only around for a few days probably because you're deploying all the time. So it's a benefit from there. In terms of rolling forward or rolling back, you're not modifying your old instances. Your old instances are still the same. They're still sitting there, and you're launching new instances. So it's easy to go back if something goes wrong. So there's a lot of benefits to doing this. So what does this actually look like from an architecture point of view? Well, the way it used to look like was this. So you would have, you would store your builds and all your artifacts in S3 ideally. So S3 is an object store, so that's the proper place to store those things. You would have a project management server with whatever software you prefer, and that would be running on an EC2 instance. You'd have your continuous integration server. That would be like Jenkins or some other continuous integration software, and that would also be running on EC2. And then your source code repo could be just plain Git running on EC2. It could be GitHub. It could be Stash. It could be Subversion. Again, whatever you prefer. And then you use Route 53 to point to the proper version of the instance when you update it and such. So we've recently announced a bunch of new services that allow you to use AWS managed options for some of these things. So last re:Invent, we launched AWS CodeDeploy. So CodeDeploy is an agent that runs on your instance, or as of last week, on-premise, and it helps you deploy your code. And it scales, so you can deploy on hundreds or thousands of instances if you want. We also announced two services that are coming out really soon. So there's AWS CodeCommit. So CodeCommit allows you to store, it's a private Git hosting, right? And then there's AWS CodePipeline, which is AWS managed continuous integration. So let's talk about these services. So before we announced these services, we had the following tools that are in this chart. So we had tools that allowed you to deploy your code, so provision your infrastructure and monitor your code. So you could use Elastic Beanstalk to bring up PHP, Ruby.NET, Python, Node.js, Docker containers. So you could bring apps in all these things with basically a 3-tier web architecture, right? You could use AWS OpsWorks to break up your application into layers and deploy on those layers based with chef recipes. You could use CloudFormation to provision things above the operating system level, so you could provision load balancers and VPCs and all that kind of stuff. And you could use Amazon CloudWatch to monitor and get metrics on all of these things you have running. But what about storing your code, building your code, testing your code? So let's talk about storing your code. So CodeCommit. So CodeCommit, again, it's private Git repositories, so it's for private Git hosting. It's ultimately hosted on S3. So one of the nice things about CodeCommit is that it's got full Git compatibility. I'll show you what that means on the next slide. But basically, you just use your existing Git binaries. You don't really have to change anything out, and you could store your source code in your AWS account running in CodeCommit. It's got all of the good benefits of AWS. So it's a scalable service. It's highly durable. It's got the durability design of S3. It's built to be reliable, and it's pay-as-you-go. So you pay for however much you use. There's no size limits on the repository, so because it's S3 based, you can store really large files and large binary files in your code repo. And it's going to have nice online code tools, so you'll be able to browse your code, edit your code, diff your code online on our console. So the way you use CodeCommit is the same way that you use Git right now. So in this example here, I'm cloning a Git repository. The Git repository is, the master of it is hosted on CodeCommit. I'm editing a README file. I'm committing the README file to my repository, and I'm pushing it up to the repository. This is really no different than how I would use Git anywhere else. So it's really simple to use. There's no barrier to entry here. Next, let's talk about CodePipeline. So CodePipeline, again, is AWS managed continuous integration and delivery. So you can build a workflow for your code going from where it's stored to how it's built to where it's deployed through different environments, so beta, staging, prod, all that kind of stuff. It's going to have support for built-in gates, so you can have manual approval gates and such, custom rules, and it's going to integrate with a bunch of third-party tools. So if, for example, you use GitHub instead of CodeCommit, you'll be able to store your code in GitHub and a bunch of other third-party partners that we have. So this is what it's going to look like. This is the web console for it. So in this example, I've got my code for my demo application here stored in GitHub. That code is going to get built, so when I push an update to that code, it's going to trigger a build in CodePipeline, and it's then going to trigger a deployment in CodeDeploy. So then in CodeDeploy, I could target different auto-scaling groups. I could have an auto-scaling group for my beta fleet, for my production fleet, and so on and so forth. So lastly, let's talk about CodeDeploy. So CodeDeploy allows you to do rolling updates with no downtime for your code. So the way CodeDeploy works, again, is it runs an agent on your instances or on your on-premise servers. You then set a schedule for how it does the updates. So you could update all of your servers or instances at once. You could do them half at a time. You could do them one at a time. You could do a custom schedule. So you could really tailor it to your needs of your application. It integrates with auto-scaling, so you could target a whole auto-scaling group as part of your deployment. And it works with really any application. So if you take a look at the documentation for CodeDeploy, it's got different lifecycle events. So before install, after install, so on and so forth. And it can copy files. It can run shell scripts. So you can either use it to completely bootstrap your instances from the beginning, or you can use it with existing tools. So if you're using Chef or Puppet, you can just use CodeDeploy to bootstrap your Chef and Puppet and get it up and running, and then get it talking to your Chef or Puppet servers, right? So it's pretty flexible. So this is what that looks like. So this is the web console for CodeDeploy. In this case, we're deploying our code for WordPress install into an S3 bucket. And this actually has not been a very successful deployment, but it's OK. So we succeeded deploying to one instance. 5 of them failed. 4 of them are skipped. So we can then configure it to roll back. As you can see, it's deploying only to half at a time. So even if half of them failed, you still have half of your instances that would be running your old code in this case, and your website would stay up. So it allows you to do all these kinds of things here. So just to reiterate, now we have tools that allow you to go from storing your code to building your code to testing your code to deploying your code, provisioning it, and monitoring it, all with AWS tools, all so you don't have to manage all this undifferentiated heavy lifting of setting these things up by yourself. So what does this look like now? So it's kind of a similar architecture to what we had before, except now we're using CodeCommit and CodePipeline. So these are 2 less things that we now have to manage in our own infrastructure. So what are some typical pain points that we see when people are doing continuous integration? So having accurate tests can be hard, right? You want to make sure that you're building tests that are complete. They're actually testing if your app is functional or not. It's often hard on premises to build a really good test environment, right? So if you're on premises and you want to have an accurate test environment, that means it has to be the same as your actual production environment. That can be expensive. That means you have to double the amount of resources that you have for production just for testing. And if you have a project that's short-lived, that didn't work out, well, you've now bought all this hardware that you have to keep just for a test environment. So it's really a big problem there. But in AWS, it's elastic. So you can bring up a test environment for a few hours that's exactly the same as your production environment, and then you can turn it off. So this solves this problem. So AWS, again, just to reiterate, it's elastic. So you can spin up 100 instances. You can turn off 95 of those instances as you need. It's on demand, so you get resources whenever you need them. And it's pay as you go, so you pay only for what you use. It's also a programmable platform. So what that means is that the vast majority of our services are built with APIs in mind. So because they're built with APIs in mind, you can automate against them and you can script against them. We've got SDKs for a lot of major languages. So we've got SDKs for iOS, for .NET, Node.js, Python, Ruby. PHP, all kinds of other things. And if there's something we don't have an SDK for, you can just talk directly to our APIs. We've also got ID toolkits. So if you're a user of Visual Studio or Eclipse, you can just install our ID toolkits, and it'll make your life a lot easier. We've also got really good command line utilities. So if you're a Windows user, we've got a really good set of PowerShell utilities. And if you're Windows, Mac, or Linux user, we've got a unified command line utility. Our unified command line utility is unified, so it's the same thing on all the platforms. It's written in Python. It's got all kinds of nice features like autocomplete, so you can do tab completion to really fill in the commands that are available. You can do easy scripting on it. The default output on our command line utilities is JSON, so it's really easy to script against that. So you should take advantage of all these things to automate your architecture and infrastructure on AWS. So again, if you can program it, that means you can automate it. So another thing that's important for automation is to use the tools that are available to do that. So I've certainly seen people use just shell scripts to do their automation, but when you get to a higher scale, there's a lot of other options out there. So there's configuration management systems. So the popular ones that I've seen out there are SaltStack, Chef, and Puppet. And there's certainly other ones as well. And so configuration management systems, what they typically do is they get your operating system to a desired state. So you describe in recipes or manifests, or it depends what they're called, depending on your configuration management system that you're using, but you basically write scripts that describe how you want your instances to look like, and the system will get those instances to that desired state. So ideally, when you're making changes to your instances, instead of SSHing in and manually changing things, you're just changing your recipes, and that gets propagated to the instances. And that ensures that everything's done programmatically and there's less room for manual error. Then there's deployment frameworks. So how do you actually deploy your code onto your instances? Again, one strategy is you could just build new instances every time you deploy. But if you don't do that, you can use AWS CodeDeploy. You can use Elastic Beanstalk, OpsWorks, and a lot of other third-party utilities out there as well. Then there's infrastructure management. So how do you actually manage things above the operating system level? So how do you manage your load balancers, your networking, your databases, all those other artifacts that comprise your stack? So CloudFormation allows you to do that, and we'll dive a little bit deeper into that. And then lastly, if you're just using containers, we now have the Amazon EC2 container service. So you can use that to orchestrate running tasks, and those tasks are really just runs of containers. And then earlier today at the keynote, we just announced a bunch of new features for that service and the fact that the container service is now generally available. So an important part of when you're spinning up new instances is bootstrapping them, right? So how do you get from a base instance, so an instance that just has the default install of whatever operating system you're using, to a desired state? So one option is to bake an image. So by image, I mean either a container or an Amazon machine image. And so that can be time consuming, right? You're going to set up your instance, you're going to install your software on it, and you're going to make an AMI or a Docker container, and now you've got this image that you can just spin up. Now the nice thing about this is that since you're doing all this work up front, when you actually have to scale up, your images are already pre-baked, so they don't have to do anything. They just turn on, they're ready to go, and they come up really fast. The other strategy is to do dynamic configuration. So what that means is every time you have to scale up, you spin up a new instance. That instance runs CodeDeploy or Puppet or Chef or some combination of these things. And every time you get the latest version of your instance that's dynamically created. The downside of this is, let's say you've got a website and you have to scale up because you've just had a lot of traffic come in. Well, if your Puppet run takes 20 minutes, that's 20 minutes that you don't have enough capacity for your website. So, that can be bad. So I like a hybrid of these two things. So I think you should use automation and configuration management and all these good things to build your images. So you have your continuous integration system building AMIs every time you change your code, but when you actually have to scale up, it already has those AMIs that it's going to bring up, and it's going to spin up, and they're going to be ready to go really fast. So let's dive a little bit deeper into CloudFormation. So again, CloudFormation allows you to describe a whole stack. So in this case, we've got a RDS instance, an auto-scaling group of web servers, and a Elastic load balancer. And so you can describe all of that in your CloudFormation template, and you can launch it programmatically and change it programmatically. So I know this is a little bit hard to see, but basically the different parts of a CloudFormation template are you've got your headers. So the headers just describe, it's the comment that describes what your CloudFormation template is. You've got your parameters. So the parameters are inputs. So you can use the same template for different things. So for example, I can have a parameter that describes which EC2 key pair I want to install in my instances. I've got a parameter that describes what instance size do I want to spin up, or what VPC do I want to launch in. So that's what the parameter is. And then we've got mappings. So let's say you've got a golden image of your operating system, and your application lives in multiple regions. And every time you copy, even if you copy that same image to multiple regions, it's going to have different AMI IDs. So this just allows you to map which AMI IDs you want to use in the various regions. Then you've got resources. So this is probably going to be the biggest section that you're going to work on in the CloudFormation template. The resources actually describe what this CloudFormation template is spinning up. In this case, we're spinning up an EC2 instance that just has a EC2 key pair installed on it. And it uses an AMI based on one of those ones described in the mapping section. And then lastly, we have outputs. So outputs are describing what actually happened after my CloudFormation template spun up. So what's my instance ID, what's the URL of my Elastic Load Balancer, so on and so forth. So let's take a look at some basic examples of CloudFormation templates. So in this example, I'm spinning up an RDS instance. The size of it is going to be M1 small. It's going to have 500 gigs allocated to it. It's using MySQL 5.5, and it's going to have a really basic username and password that you should never use in production for good security practices, but just for an example here. Then we have another CloudFormation template here. So what this is doing is this is bootstrapping your instance. So this is going to be a part of a description of an instance resource, and it's telling the instance to install the packages I've listed there onto my instance, and it's telling it to download a zip file from an S3 bucket and extract that zip file in my web root. So just for this basic bootstrapping, I will get a MySQL client, MySQL server, Apache, PHP, and a fully baked website bootstrapped really quickly. So again, in this case, they're bootstrapping it on the fly. They're not using pre-baked images. So lastly, here's an example of parameter. So again, I'm just asking what EC2 key pair should I use so that I can SSH into my instances. And this is what it actually looks like when you're launching the template on AWS. So just to reiterate, there's a lot of advantages of CloudFormation templates. It's a known configuration, so every time you launch the CloudFormation template, you're going to get the same thing because it's doing the same process to launch it every time. It's a procedural definition, so it's JSON, right? So it's created programmatically every single time. Again, it's going to be consistent. It's parameter driven, so you can have one CloudFormation template that allows you to spin up multiple different environments using parameters, and it allows you to collaborate. So ultimately, a CloudFormation template is just a file. You can store that file in your source code repository. You can share that file, so if one of your developers wants to spin up a test environment that's exactly the same as your prod environment, you just send them your CloudFormation file and they can launch it. So it's got a lot of nice things that you can do with it. So if you want to get started with CloudFormation, I would highly recommend looking at our website. If you look at our CloudFormation section of our website, we've got a bunch of demo templates on there, so you can spin up a multi-AZ Drupal install. You can do all kinds of advanced things. There's a SharePoint CloudFormation template that allows you to spin up a fully baked SharePoint environment. So I would usually, like when I work on a CloudFormation template, I usually take one of these as a starting point and just modify it from there. So because of CloudFormation, you can now think of versions of not only your application, but versions of your actual infrastructure. So you can then, again, store your CloudFormation template with your code, and you can have your continuous integration system. Every time you deploy, you're not only deploying your application, but you're spinning up a whole new version of your infrastructure, which is really, really powerful. So this allows you to continuously deploy, which means, again, you're going to have small, frequent changes into your code, and this makes these changes a lot less scary. And the key is it's iteration, right? So iteration means you're modifying your system to better meet the expectations of your users. So it's not a product launch, which is like this giant monolithic thing, right? So let's talk about an example from inside of Amazon, from Amazon Retail, about how we do deployments for the retail website. So these are some stats from 2011. So in 2011, there was about an 11.6-second mean time between deployments on a weekday. There's a maximum number of about 1,000 deployments in any single hour, and about an average of 10,000 hosts receiving a deployment at any given time, and a maximum of 30,000 hosts receiving a deployment at any given time. We just released new stats actually recently. So last year, we did 50 million deployments in 2014. That means one deployment every 1.5 seconds. So again, a deployment is not a software launch. If you're deploying multiple times a day at this rate, you're doing very minor, small changes, and if there's a bug in those changes, you can easily just make another deployment and fix them, and it's not going to be a disaster. So another thing that's really important as part of DevOps, I think, is to have data-driven architectures. So what does that actually mean? Well, let's take a look at what some of our customers are doing. So Etsy, they have this in their office. They just have this giant screen or giant wall of different TVs with different metrics on them. So this could be the availability of their apps, how many sales they're doing, all kinds of useful metrics. And this isn't in the area where just the developers are. This is in their main floor, so everybody can see it. So everybody's exposed to metrics, and this is called visible ops. At my previous job, before Amazon, so I used to work at the Obama campaign, we had a similar thing. We had screens all over the place that showed how many donations we were taking in, what the latency of our website was, all these kinds of useful metrics. So everybody in our tech team, developers, systems administrators, product managers, people who were executives, they all saw what was going on, and they all felt that this allowed you to not have people throw things over the wall to different, and allow there not to be silos. So all kinds of positive effects there. So at the Obama campaign, this is one of the metrics that we had. So this is basically a time series chart that shows you kind of how different systems depended on each other. So these are all just different apps, but a slowdown on one app, could result in a slowdown on another app. So if our identity system was slow, that would ripple through all these other systems, and this would allow us to understand and see how our systems impacted each other, and we could then mitigate different kinds of issues. So to help you do this kind of monitoring, there's a lot of options in AWS. So the first thing that you should do is take advantage of AWS CloudWatch. So CloudWatch gives you all kinds of metrics on our services. So for example, for EC2, you get CPU usage, you get network bandwidth, in and out, all kinds of useful stuff. On top of that, you can inject custom metrics. So you can have whatever metric you want, tweets per hour. Anything that you can possibly think of, you can inject it into CloudWatch. For RDS, you get things like number of connections. So each service has different kinds of metrics that it gives you. You can then create alarms off these metrics. You can scale up and down off these metrics. You can inject these metrics into your monitoring system, get alerts off of them, all kinds of powerful things. Also, CloudWatch gives you logging. So we have a product that we launched last year called CloudWatch Logs. So there's an agent that runs in your instance, and it sends all your logs to CloudWatch, and then you can search your logs. Again, you can alert on them, do all kinds of stuff. On top of that, we have a very rich ecosystem of partners that give you application monitoring, endpoint monitoring. And these are just some examples of the options that we have, but I encourage you to walk around our vendor booth area today and see what some of these options are and see which ones work for you. So just to reiterate, continuous integration means that you can then have continuous deployment. Continuous deployment means you can always experiment. The risk of failure is low, and the cost of failure is low, so you can fail fast instead of having to avoid big failures. You can continuously improve your product, and this means that you can innovate on behalf of your customers, and this is really powerful. So just to reiterate, on AWS, you can experiment really often. Failing is cheap. Failing is okay because it's a small failure that you can quickly recover from, and this allows you to innovate. All these things on premises are a lot harder and much bigger problems. So now I'm going to have Dave Beck come up here, and he's going to talk to you about National Novel Writing Month's journey into DevOps. Thank you.
I found myself thinking about skipping this part of the presentation so I could go back and revise my architecture plan based on what Leo just said. So take everything I say with a grain of salt, because now I'm thinking a little bit differently about what we're going to do. I'm the technical director at National Novel Writing Month, also known as Nanowrimo, and you can see that comes from the words National Novel Writing Month. Do we have any Rhymos in the audience today? I know we've got 1, 2. Awesome. I hope you're participating in camp this year. We are an organization that encourages creativity through writing. And every November, we host a writing event where people attempt to write a whole novel in the month of November. Last year, we had about 180,000 people define novels, and 40,000 actually finished during that month. We're not necessarily about publishing, we're about creativity and self-empowerment, and we found that many of our participants actually go on to have better careers, better social lives, et cetera, because they participated in NaNoWriMo. This started in 1999. Our founder, Chris Beatty, was kind of a beach bum. He challenged 20 of his friends to go out and write in 1 month, and 6 of them finished. And over time, we had, well, what we call explosive growth. I'm sure this is a fairly shallow slope for some of you. But for us, it was explosive because we had no staff and no budget. So around about 2009, 2010, we found that we just could not manage the kind of growth we were having anymore. And so, well, first let me tell you about our sites. We've got 4 sites right now, Nano Main, running older versions of Ruby and Rails and MySQL. Camp Nano runs in April and July. And then we've got the Young Writers Program geared toward teens and younger kids and the schoolroom setting in Drupal 5. Anybody else here still on Drupal 5? None. No, this is our organization. It's all kind of cobbled together. And we also have a store on Drupal 5. Well, those last 2 pieces are actually getting replaced with Rails this year. So we get to get off Drupal 5, and hopefully that saves us some heartache and some server resources as well. Here's a look at the essential problem of NaNoWriMo. We have very little traffic all year, and then on November 1st, it just explodes. And we could not handle this without AWS. So what AWS offered us beginning in 2011 was the ability to spin up to about 100 servers for a day or 2, and then slowly start spinning them down over the month. And that's been great. Our infrastructure, however, is a little bit messy. This is great, actually. So our site crashed every November 1st from 2003 to 2011. And we finally migrated in 2012, and we had no more outages. The site did not crash. And as a result, our participants were outraged. They saw this as kind of a badge of honor. Bringing down the site was what they loved to do every November 1st. So, I don't know, that's kind of a negative about AWS, I guess. So right now, we've got kind of, like I said, it's all cobbled together. We've got proxy servers running Varnish on Debian Wheezy, some Ruby on Rails, Rask, Redis, Sphinx, usual suspects, right? And we're using EC2, we're using S3, we're using RDS, EBS, and some other services as well. However, in my job as technical director, I direct 4/5 of a Rails developer. And then there's me. So we have no resources to manage this. And really, I could spend all my time working on AWS if I wanted to. I don't want to. I want to code. I want to work on our programs. And I work on our mission. So we love this new model. We want to move to it. Now, here's a look at our instances last year. Excuse me one moment. You can see how things go. We actually have a fair number of instances because we're running multiple sites with different code bases. So we have to maintain those and proxies and everything associated. And you can see how things spike in November. And we are just super careful about pushing up and pulling down instances because our budget is razor thin. So we love this new model. And the reason is really because we're shifting to a new idea of how we work. So in the past, we hosted this event, and we spun up all these instances once, and we spun them down, and then we sat around for a while and waited till next November. Did some code work, did a deploy once or twice over the year. Well, it's all changing. We're trying to actually host instances of the event throughout the year. And so we need a way to manage our infrastructure so that this does not take all of my week every week to do. And so, love this new model. Our goals, first of all, are save me time on server architecture tasks. Number two, increase the uptime for all services. And we found with our old sort of custom scripted stuff, literally written by volunteers over the years, things would go down inexplicably. So we need reliable solutions. To quickly respond to user-driven events, this means like emails when somebody finishes their novel. To reduce EC2 costs through auto-scaling, meaning that I don't have to project, well, maybe we're going to get this much traffic, spin up the instances, and then I'm either wrong and we get 404 errors, or I'm wrong the other way and it costs too much. So we're moving toward auto-scaling as quickly as we can. To create a faster and more dynamic email system, we're using a very old open source email system called PHP List, and it's just not working very well for us at the moment. And to improve site search. For steps, goodbye Drupal, of course. Seems an obvious step, but I don't know. One of the things I was thinking was really good about Drupal 5 is it must be secure now, because who's hacking Drupal 5? We're going to move our email systems onto Amazon SCS. Very excited about this. And going to elastic load balancing and auto-scaling so that I don't have to think about exactly what we're going to need, and the system can just work automatically as we spin up new events. Definitely using CodeDeploy. I really want to get CodePipeline and CodeCommit in there, but those haven't been released yet. So as soon as they are, that's where we're going, most likely. And of course, auto-scaling. It has to happen for us. One other thing that I just really want to tout is the SNS notifications. They've been extremely good for us. Basically, I get a text anytime there's any sort of server-based event, and we can get on the problem within seconds, literally, and that's been wonderful. So I want to expand that to include all the services that are available to us. And looking at using cloud search potentially for search features. We're currently using Sphinx, and we probably go in once a week to fix some bug. Something goes down, the server goes down, the gem goes down in Ruby on Rails. I'm very curious about Lambda as well, but we haven't quite figured out how we might use that. And if anybody has any actual stories about that, I'd love to hear them. And so our architecture then hopefully becomes something like what Leo just showed, but an architecture where I don't have to be an AWS expert anymore. I can go off and I can write the Ruby code. Heck, I design web pages as well. I'm doing all the work for this organization around the tech side. And just let this thing run, and that's my goal. We may not get there, but if we do, that would be totally lovely. And I'm sure Leo's going to hear from me in the future about how best to do this. Should we take some questions?
Yeah, so we've got a bunch of time here, so there's a microphone up here, so if anybody has any questions, we'd love to take them. All right, so yeah, if you have a question, just walk up to the mic up in the middle here. Hi. Yeah.
When are those, the code pipeline and the other tool going to be available?
Soon.
Nothing more specific?
I think we announced that reInvent, so something Q2, 2015. All right. Yes.
One of the challenges people face in terms of their code deployment and builds is the automated secure control of, say, the utility accounts that are used to execute.
Yes.
Do you have any slides or any thoughts on the solutions that you're going to offer as part of this matrix?
So CodeDeploy, the way it actually works, AWS CodeDeploy works through IAM roles. So you don't actually have to have SSH accounts on your instances just for CodeDeploy. So that'll help you out there. Yeah.
How are you managing things like mapping a particular branch, like a feature branch or a particular version branch to a particular environment?
So one way I've seen this done is you use Git tags. So you have a tag for each version, right? And then you have your continuous integration system configured to, so an operator can go in and say, I want to deploy this tag. That's a manual process. Another way that I've seen this done is through service hooks. So GitHub has service hook. Regular Git has, post-receive hooks, right? So you have a hook, and you can configure the hook in different branches, or you can configure it the same way so that the branch is a variable. So that'll, kick off your continuous integration system, which will then know through that variable what actual tag or branch it needs to deploy off of.
One last question.
Sure.
You had talked earlier about, just one of your slides showed test results getting immediately put into a project management system. We've actually done that using Redmine and having test results get mapped into there. It'd be a test management plugin. But is Amazon planning on doing anything like that to make that easy to do?
So I'm not sure of any specific plans, but I know that CodePipeline is going to have easy third-party integration. So it wouldn't surprise me if you'll be able to integrate with one of those tools.
Thanks.
Thank you.
Thank you, by the way. It sounds really amazing. We're definitely going there tomorrow if you deploy
Awesome.
tomorrow. Which is actually my question. So currently we have a system with Chef and Jenkins and our builds, maybe 100 different builds and 20 different Chef recipes. Can you talk a little more about what do you envision the migration to be from that continuous integration system today to this?
Yeah, so if you're using Chef right now, going to OpsWorks would be really easy. So you can literally take the vast majority of those Chef recipes and just drop them into OpsWorks. Wow. So you set up your instances in OpsWorks, you set up your layers. So the way OpsWorks works is you imagine your application, you break it into layers. So you've got your web layer, your app layer, your load balancer layer, whatever your application looks like. And then each layer of instances is going to have different lifecycle policies. And then at each lifecycle event, so pre-install, post-install, all those kinds of things, you can have it kick off different Chef recipes. So you literally just have to take your Chef recipes and figure out where they go. So the migration in your case should be pretty easy. I'm not sure what the migration from Jenkins to CodePipeline is going to look like, but I know that CodePipeline is actually going to have integration with Jenkins at the beginning. So it shouldn't be super difficult, I would imagine.
If you don't mind, anyway.
No, go ahead, sir.
No, I forgot what it was.
Okay. Hi.
Hi. So right now, for example, we are partnering with external applications.
Sorry, can you talk closer to the mic?
Yeah. So we say, for example, we are partnering with external applications where we cannot spin off multiple instances on the go. Would the CodeDeploy or the CodePipeline be smart enough to understand what the environment is like and make decisions accordingly? Like, for example, one version is out and the other one cannot coincide with the same.
Yeah, so CodeDeploy, just last week we announced that it works on premises now as well. And CodePipeline just plugs into CodeDeploy, right? So whether your CodeDeploy instances are instances or there are things that are on premises, it should still work. Ultimately, you're kicking off a web accessible URL. So as long as CodePipeline can access the agents, you should be fine. Hi.
Hi. Is CodePipelines, comparing that to the Amazon's internal pipelines feature, is that going to be a slimmed down version? Is it going to be completely different, or?
All I know is that it's heavily influenced and based on our internal tools. So I'm not sure what the delta is going to be.
Okay.
Thank you. All right. Any other questions? There. Looks like we have.
Hi. I had a question about your slide about the Amazon internal deploys, where it was deployed every 11 seconds. Is that like A/B testing? Was that deployed everywhere?
So the way that works is, Amazon retail practices service-oriented architecture. So Amazon.com is not like one monolithic website.
Right.
It's a bunch of microservices essentially. So that's why there's so many deploys going on, right?
Oh,
So
gotcha.
There's things getting updated, but not the same things all the time.
Okay, absolutely makes sense. Cool.
Okay, thank you.
So my question has to do with CloudFormation templates. That look very cool. What happens when some of the things depend on other things? For instance, if I'm going to set up a DNS with Route 53, I first need to instantiate the instance and see what elastic IP I get before. So how does it work?
So there's different things you can do. CloudFormation templates has this concept of nested templates. So you could have a separate template for your VPC. You could have another template that's just for your RDS. So you don't have to have like one monolithic template. But on top of that, CloudFormation also has wait conditions. So you can have it wait for certain things to complete before doing the next step. And it has dependencies as well, actually. So. All right. Any more questions? All right, well, thank you.